Good evening, बच्चों. Good evening, everyone. I hope we are live. Please, everyone, be active on the chat box and let me know my voice is crystal clear or not. So, in yesterday's session, what we discussed, I think we talked about acceleration wala part. And acceleration analysis, mein we have seen that general questions of accelerations are actually not a part of GATE examination. Why? Because not because it is very tough, just because it is a little lengthy. है ना, velocity analysis, doing velocity analysis is a little easier. It takes a little lesser amount of time. है ना, just draw a vector and you will find a point. From that point you will draw another vector. For the acceleration purpose we have to draw two vectors, radial component, tangential component, and then we will get some acceleration. And then we get some point, and from that point again for another point we will talk about radial acceleration, tangential acceleration. So it becomes a little lengthier. है ना, correlates wala part is on the other hand is something which is very much asked in GATE examination. Why? Because it is very easy to, very less time taking conceptual question. GATE is all about conceptual questions, not very lengthy calculative questions. So in the same series we will be talking today about another chapter which is gear. What are the gears? How do they work? What are the key concepts inside in this chapter? How questions will be framed? What is interference? We will discuss all these things. Where they are going to ask question, first of all, let me frame that thing in front of you. What portions will be covered for the GATE examination? GATE examination mein, although this gear chapter we will study in two parts. First we will talk about gear and then we will be talking about gear train. Gear train is something which is, having smaller questions. Quickly they can be solved, and GATE mein this is asked very much in objective format. On the other hand, the gear questions today, whatever we are going to cover, this is mainly more important for the subjective examination. Why? Again, because here chances of asking lengthy questions is quite high, but for the objective question also sometimes they ask few portions. What are those portions? First thing everybody must know, terminology related questions, basic questions, है ना, what is circular pitch, what is module, what is pressure angle, how to increase or decrease pressure angle, what is addendum, what is dedendum. So they can ask these kind of questions, terminology related question. And even if they are not asking terminology related questions directly, but this terminology part must be very strong. Why? Because question mein whatever language they are going to give, if you want to be able to understand that question, you must be very much familiar with this terminology wala part. Akhir in this entire gear, if I have said some word ki bhai addendum is something, so you must know, you must feel what addendum is. Second thing, questions they are going to ask about analysis of involute gear, because involute is in our syllabus. Although there are two conjugate profiles, we may have gears which have involute teeth, we may also have gears having cycloidal teeth, but cycloidal teeth is not generally used in market, as well as this is not in our syllabus. In our syllabus only analysis of involute part is there. So analysis related questions they can ask. Here they can ask, tell me what is the path of contact, tell me what is the arc of contact, tell me what is the contact ratio, etc. These are the questions which can be asked. And last but not least, interference question can be asked here also. What is interference? How to reduce this? Number of teeth, minimum number of teeth. Tell me what is minimum number of teeth required to avoid interference. So these are the portions where questions can be framed. If you'll just go through the PYQs, you will find that outside this boundary which I have drawn here, questions are not asked. Let's decode one by one each and everything. First of all, let me talk about how a gear looks, and in that gear there are some terms which are going to be used inside this chapter. I will discuss only those. Suppose, and to explain this terminology wala part, what I'm doing is I'm making a very small portion of big gear. I will take 2-3 teeth, and 2-3 teeth, I'm just zooming in that picture how that thing is going to look. If we'll see 3D, if I'll make a gear, it looks like this. We are going to have teeth looking like this. If I draw it in 3D, we are going to have something like this kind of situation. Then we'll be having another teeth. Whatever I have made here, the same thing we are going to have here also. Another teeth we are having. So on the same circle, another teeth is there. Another teeth, and so on. We are having this kind of situation. 2 teeth I have shown. So from wherever your teeth is starting, you are having a big gear like this. From wherever your teeth is starting, that is called as dedendum circle. This is called as dedendum circle. Dedendum circle, or some people also call it as root circle, beta. Dedendum circle or root circle. If I draw a circle which is passing from the tip of the tooth, this is called as addendum circle. This yellow color ka circle which is passing from the tip of the teeth, it is called as addendum circle. Addendum circle. There is another circle, very important circle, which is your pitch circle. This is your pitch circle. Acha, to understand the concept of pitch circle, what is this pitch circle? Let me go a little back. I'll come back to this terminology wala part once again. Sir, how this concept of gear was started? Earlier in the classes also I have told you that while making gear, I had in my mind a simple logic कि भाई from one shaft I want to transfer, one shaft पे I have connected motor, so shaft is rotating, and this shaft का rotation I want to transfer onto another shaft. So one shaft, it is perpendicular to the board, and on that shaft a student suggested कि sir, do one thing, connect a frictional disc on it, a disc kind of thing. Frictional disc means this surface is very rough, and this disc is rotating, and you want to transfer, shaft is rotating, on the shaft we have mounted a disc, so disc is also rotating with some 𝛚1 speed. We have this disc rotating with some 𝛚1 speed, and its radius is given as r1. Another shaft is there where you want to transfer this rotation, so this is the shaft which is waiting. On this shaft you have connected another disc kind of thing, it is also frictional disc. It looks like this, ऐसा कुछ. It is rotating about this fixed axis. Its radius may be same or may be different, so I have shown it different. R2 radius, and both these frictional discs, they are in contact. So by this direct contact, at this point these discs are in contact. So one disc is rotating 𝛚1 angular velocity से clockwise direction में, and because of the friction here, this disc will make another disc to rotate in anti-clockwise direction, because we have shown this external meshing kind of thing. So obviously this will start rotation with some different 𝛚2 angular speed. And imagine if there is no slipping happening here. If at this point there is no slip, so I can say that 𝛚1 by 𝛚2 It is not going to change. It will remain constant. Getting your point, sir? Otherwise, if slipping is not happening, so contact point ka velocity in this direction, whether you write from the point of view of disk 1 or from the point of view of disk 2, it will be same. What does it mean, sir? Contact point ka velocity of contact point, it will be r1 omega 1, or from the disk 2 if you'll ask, so it will be r2 radius pe omega 2 se you are rotating, so it will be r2 omega 2, and both are going to be same if slipping is not happening, if no slip is there. And if this is happening, so can I write omega 1 by omega 2, which is r2 by r1, and r2 by r1, this radius ka ratio is constant. That means omega 1 by 2 I am going to get constant. And this is the purpose of gear. Why something can be called as gear if it can transfer motion or rotation from one shaft to another shaft in such a beautiful manner that omega 1 by omega 2 doesn't matter how slow or high speeds we are moving. Omega 1 by omega 2 ratio should not change. Ratio should not change. What does it mean? That if I am rotating this with 10 RPM or 10 radian per second, so its velocity I am getting 5 radian per second. So what is the ratio? 2:1. It is rotating at double speed of this. So if I increase this speed to 50 radian per second, so its speed should also increase, maintaining the ratio constant. Earlier it was rotating with 10 radian per second, so its speed was 5 radian per second. Its speed I have increased to 50, so it becomes 25 radian per second. Even if I increase the speed to 100 radian per second, so its speed will be 50 radian per second. This ratio should maintain. Its ratio of the speed should be constant. If I can have this beauty, then I can call this body as gear. Acha, sir, even if you are simply sitting, if you are simply trusting on the friction, ki bhaiya theek hai, because of the friction only motion is getting transferred. Is static friction, hai na? Here static friction is going to act. If you are simply dependent on static friction, there are chances that at high speed slipping may occur. So to avoid the chances of slipping, what I am doing, I am just creating some teeth here. How those teeth are going to look? These are the frictional disc. These are the circles on which I can imagine that pure rolling is possible. So just to avoid chances of slipping, I have created some teeth on it. And how those teeth are looking? These teeth are looking like this. This is how we have created teeth. This is how we have created teeth. Like this. Here also. And on the other gear, here also I'll be creating some teeth. How those teeth are looking? So those teeth will be looking like this. And can you see the diagram clearly? Can you see? How many of you can see that, sir, whatever teeth I have made, these teeth are starting below the frictional disc and these teeth are extending beyond the frictional disc. This frictional disc I am calling it as frictional disc, where I could imagine the pure rolling motion. Without slipping, I could imagine the rolling motion, pure rolling motion. These discs will be called as pitch circle of my gear. And portion of the teeth, if you will see, some portion of the teeth is below the pitch circle and some portion of the teeth is above the pitch circle also. I hope this is clear to everyone. And why you have created teeth? Because, sir, once teeth have been created, so these teeth are interlocked with each other, and this interlocking is guaranteeing that while rotation, doesn't matter how slow or high or at high speed I am moving, this slipping is not going to happen. Clear hai baat? Is this clear? Again, coming to this part, sir, what is this pitch circle? I hope now everybody has got it. So pitch circle is something where two gears were having pure rolling motion, and then we have made some teeth. Teeth is starting below the pitch circle, extending beyond the pitch circle. And once I have made this gear, so only gear will be visible to you. This yellow color wala thing will be visible to you. This white color wala thing is gone. You will be having this gear. But if I have to show two gears in mesh, I will simply represent them with the help of pitch circles only. That these are the pitch circles which are rolling over each other without slip, because teeth have been created. So actually teeth have been created, but I am showing them with the help of this pitch circle. ठीक है ना? And this pitch circle is very, very important circle. Why? Because rolling motion is happening here. The concept of gear has started from it. So there are so many things which we are going to measure either along the pitch circle or from the pitch circle. If somebody is asking me, tell me what is the how much tooth is above the pitch circle, so I will measure this distance. I also want to know how much teeth is below the pitch circle, I will measure this distance. So this distance is called as, radial distance is called as addendum. Addendum. And this distance below, it is called as dedendum. If total distance from addendum circle to dedendum circle, yani ki this addendum value and dedendum value, if I add this, so that total thing is called as total depth of the tooth. Total depth, you can call it as total depth or total height, nothing but same. Another very important feature, sir, if I have to measure tooth ka thickness, you can see, sir, tooth ka thickness is varying. Here it is very small, it increases. So tooth ka thickness is varying across entire height of the tooth. Tooth ka thickness is varying. So if I have to measure the tooth ka thickness or space of the tooth, so I will measure along the pitch circle. Kaise measure karenge? Sir, from here, this distance, it is called as thickness. So this distance I am calling it as thickness. This straight distance is called as thickness of the tooth. And from here till this point adjacent, this distance is called as space. So we have thickness, tooth ka thickness, and this is space. And if from here, if you will directly connect this tooth ka thickness plus space, how much is this distance? This is called as pitch of the tooth. I have thickness of the tooth, I have space of the tooth, and then total thickness plus space is called as pitch of the tooth. If this entire thing which you are calling it as pitch, if you measure it along the circular pitch circle, this arc wala dimension, this is called as circular pitch. So what is circular pitch? I hope this is clear to everyone. So let me show this arc ke form mein whatever thing you have, it is called as circular pitch. Circular pitch. Let me write some here. Sir, from here till this point, arc ke form wala dimension, this dimension along the pitch circle, it is called as circular pitch. We denote this by PC. P suffix mein I have C. It is how we are going to denote this. Circular pitch. Clear hai baat? So what is the addendum value? What is the dedendum value? What is the thickness? What is the space? What is the pitch? What is this circular pitch? I hope this is clear to everyone. And one logical thing, without getting into much derivation, mathematical part, can you say one thing clearly just by looking at this diagram? By if this gear is to mesh or engage, two gears are engaged with each other, we call it technically that these two gears are matting, these two gears are meshing, these two gears are engaged. So if this gear has to engage with some another gear, so one common sense wali baat, another gear ka tooth, that tooth will be inside this space. Yani ki thickness wala part of other gear, thickness will be inside this space, and its thickness will be inside the space of the other gear. So if I am having two gears, gear 1 and I have gear 2, we have thickness, we have space. So if gear 1 ka thickness, suppose if gear 1 ka thickness, I have said thickness is 6 mm, so this 6 mm will go inside the space of the other gear. So other gear must have how much space? Sir, can it have 5 mm space? No, not possible, because inside the 5 mm space 6 mm thickness cannot be inserted. So obviously baat hai, the 6 mm will go inside a space which is exactly equal to 6 mm. Obviously baat hai, its thickness should be equal to this space. And gear 2 ka thickness, if suppose this thickness is 4 mm, so it will go inside the space of other gear. So this is 4 mm thickness, this other gear ka space should be 4 mm. यानी कि कॉमन सेंस वाली बात, बोथ दी गियर्स, गियर 1 के लिए थिकनेस प्लस स्पेस 10 mm and gear 2 का thickness plus space 10 mm, it must be exactly same. यानी कि pitch of the gear 1 gear 2 must be same, otherwise these two gears cannot engage together. Pitch must be same, or we can also say circular pitch also be same. Getting my point or not? Circular pitch must be same. Both the meshing gears ka circular pitch must be same. How you can say this, sir? By the common sense logic. First observation, sir, can I say both the gears ko I am going to show with the help of their pitch circles. How these pitch circles I am going to represent? Sir, one pitch circle I have shown it here. Sir, this is a small gear. We are habitual of calling this a smaller gear as pinion. This is my pinion. A smaller gear, pinion. And this gear, I have shown it by its pitch circle. Another gear ke saath it is going to meshing. Yellow color se I have just shown it. This is the bigger gear. This big gear. Big wala gear is called as gear. Pinion and gear. Always. What is driver, what is driven, I am not interested in that. Whatever is the smaller size wala body, I will call it as pinion. Bigger size wala body go, I will call it as gear. Pinion and gear. Most of the time you will see that pinion is driver. Driver, mostly it is made driver. Why it is mostly made as driver? Because most of the time our intention is to reduce the speed. Why? We call about motor, or we call about gear engines. Motor ho ya engine ho, they are having high speeds. So I have input can be given by motor or engine. Input mein we are having high speeds. Practical applications ke liye I want to reduce the speed. Say for example, if I am talking about my automobile. So automobile mein what do we have? My engine is running at 1500 rpm. Even in the idling condition, just start your bike and don't accelerate it. Simply just release the accelerator. Minimum fuel supply your engine is withdrawing, and still it is running at 1200 1500 rpm. Because we have to complete the suction stroke, compression stroke, power stroke, exhaust stroke. So this entire thing have to have at some minimum speed. That speed is 1200 rpm, 1500 rpm. Your automobile is running at 1500. Automobile ka engine is running at 1500 rpm. If you accelerate this, so this 1500 rpm increases to 2000, 3000, 3500 rpm. Hai na? So even at the lowest fuel supply, minimum rpm is 1500 rpm. So it is not like that bike ko I have started and my engine ka speed is 1500 rpm. This 1500 rpm is, I just applied first gear. So this 1500 rpm is connected to wheel and my wheel was stationary. Suddenly it started running at 1500 rpm. My bike was here and suddenly my bike started running. Nahi, it, it took off like aeroplane. It was standing and suddenly 1500 rpm se wheels started rotating. So my, bike went from 0 to 100 like in 0 second. I don't want it. I want output speed should be very, very less. 1500 rpm se engine ka parts, engine ka shaft is rotating. I want output ka speed as 50 rpm, 100 rpm. And then slowly engine is running at 1500 rpm. First gear mein I want to run my wheel output at 100 rpm. Then second gear I shift the gear. Now I want output speed 300 rpm, 500 rpm. Third gear 1000 rpm. Fourth gear I want my speed to be 1500 rpm, which is same as engine. Most of the vehicles में output का speed will be same as the engine का rpm when you are running at the top gear, है ना? And that's why, because input में we are having higher speed, I want to reduce that speed. That's why pinion is generally made driver. Output wala gear is bigger size, so its speed will be reduced. Sir, isn't the reverse possible? If I connect the motor here, so motor will rotate at 1500 rpm. Output I want to take from here. So if it is running at 1500 rpm, output will be at higher speed. Can we do this? Yes, you can do this. But generally this is not the case. Clear hai? And that's why most of the books they have simply started writing that gears are speed reduction devices. Why? Most of the time I want to reduce the speed. Okay. Acha. These are the two gears which are meshing. I have shown them by pitch circles. Where are the teeth? Sir, teeth is radial direction mein. Radial direction mein we are having teeth. Another teeth we are having radial position mein. Another teeth we are having radial position. And these are so many teeth. And these teeth are going to engage. One teeth, suppose this is driver and this is rotating in clockwise direction with some omega pinion. Clockwise direction mein it will rotate the other body with some different speed, omega of the gear. We are having teeth here. This teeth is coming and here radial direction mein some teeth were waiting. So this teeth of the pinion will be applying some force on the teeth of the gear. They are touching somewhere at this location, and when these teeth will further proceed, so contact point wherever teeth are touching, so that real physical contact point will travel also, and somewhere here they will disengage, so contact ends. So contact will start, it will travel contact point, and then they will disengage. So contact point will keep on moving, but both these gears ka pitch circle is going to touch always at this particular point, which is called as pitch point, where pitch circles are touching each other. It is the point which is called as pitch point. बहुत ध्यान से समझना. This is the pitch point. Pitch point is not going to change its location. Contact point will travel. Pitch point will always be at the same place. And on the pitch point, if you draw a common tangent to both the circles, this is the line which is not going to change, fixed line. My pitch point is not changing. So pitch point pe if you have drawn the tangent, it is also not going to change. So this is common tangent we have drawn. Common tangent at pitch point, and this P is your pitch point. बताइए. So what are the pitch circles? What is the pitch point? What is the common tangent as pitch point? One thing I am writing here, everybody must know that there are so many circles I have drawn in the gears. We have addendum circle, we have addendum circle, we have pitch circle. But market mein whatever gears are available, that size of the gear is expressed in the terms of pitch circle diameter. Kyunki I have started the concept from the pitch circles just to pay the respect. Otherwise, by addendum, sir, if I tell the addendum circle radius, don't you get the idea of the size of the gear? I will get the idea of the size of the gear. Same thing you can also express in the terms of diameter of the addendum circle. Even that will give me idea of the size of the gear. If addendum circle radius is quite high, I will assume that, oh, gear is big. But just to pay the respect, because concept has been started from pitch circle, so size of the gear is expressed in the terms of pitch circle. Why it is necessary? We are just paying the respect. Can't we represent the size of the gear in any other circles term? We can, but we are doing this. We are expressing the size in terms of pitch circle diameter. Size of gear is expressed in terms of pitch circle diameter, PCD, and most of the time we are talking about small gears, so it will be given in mm. ठीक है, unless we are talking about big size gears, है ना, some crane का gear that is big, so then we can talk in terms of centimeter or meter, but most of the time you will be seeing pitch circle diameter will be provided in mm only. Acha, then you have also talked about circular pitch. What is circular pitch? Let me write, sir. Circular pitch, it is denoted at PC, and I just have seen circular pitch of both the meshing gears must be exactly same. How this circular pitch can be expressed? Sir, circular pitch can be simply expressed like this. What is this? This distance, arc ke form mein this distance is called as circular pitch. How can we find? By, if you know the entire pitch circle ka perimeter, what is this perimeter? If you know this, and if you are having 10 teeth on the pitch circle, so with one teeth, how much portion is associated of this pitch circle? This portion, teeth ka thickness and adjacent space. This is circular pitch. So entire perimeter of the pitch circle divided by number of teeth, if you will do, you will get this value, a small value. So I can express this circular pitch as perimeter of the pitch circle, which is pi d. Diameter of the pitch circle is d. Pi d divided by number of teeth. This is how we can write circular pitch. And once you have circular pitch with you, can I simply say by logic कि meshing gears के लिए PC1 must be equal to PC2. I'm not saying it should be same, na, it must be same, otherwise gears cannot mesh. ठीक है, meshing gears के लिए this PC1 must be equal to PC2. PC1 is nothing but pi d by t, यानी कि one gear का pi d1 by t1, it should be exactly same as pi d2 by t2. ठीक है, अच्छा, if this pi gets cancelled, so we are going to also have d by t of first gear must be same as d by t of the other gear. This is another term. We call this term as module. There is a term which is called as module, module m. From the small m I denote this. What is the module small m? Small m is denoted as d by t term. By this pi gets cancelled, d by t must be same. D by t term very frequently we will see. So we have given it some different name, module. And no need to explain this, ki bhaiya module also it must be same. Why? This is coming from here only. So if circular pitch must be same, then module must also be same. For meshing gears, M1 must be equal to M2. It must be same. You don't have choice. If modules are different, these gears cannot mesh. Gears must have same module. Acha. Whenever we are calculating circular pitch or module, we calculate these things in mm. You know? Put the diameter in mm, circular pitch will be in mm. For module, I will put the diameter in mm, module will also be in mm. So in our entire syllabus, you will find module, circular pitch will be given in mm only. Sir, both these things I am going to use as local units, and try to understand this thing. Most of the people fail to understand this. PC and module as a local unit. Local unit का मतलब क्या होता है? Sometimes देखो, if you are going to ask me what is the size of this board where I am writing, what is the size of this board? So I can simply either tell you that size of the board is 300 centimeter, समझिए, or 100 centimeter. But most of the time 100 centimeter, I am not getting feel of this. Sir, I know how much 100 centimeter looks like. If you will give me the scale, I can measure how much 100 centimeter is. I'm not saying that I don't know what is 100 centimeter, but I don't feel it. But if I'm standing in front of you and I'll say that this is my one hand, so this board is about 2 hand. How long this board is? 2 hand. So when I'm standing in front of you and instead of using 100 centimeter, 200 centimeter, if I use this hand like this, ki bhaiya, this is my hand and two hand, this much is the length of my board. So it gives you better feeling, better idea of the size. This is the meaning of local unit, that I'm standing in front of you and I'm showing you my hand and two hand, three hand, this is the distance. बात समझ में आ रही है? Sometimes for the better communication, for the better feeling, we common language we start saying distances. My distance and my girlfriend's home distance from my house, her house is around 10 steps. Distance should be told in terms of meters, kilometers, but we call it as 10 steps. Sometimes we express this distance as 2 minutes distance. Getting my point? So just to get the feel that this is very, very close to my house, I can express in some different units, local units. So till the time that local unit is expressing the feel, I can use it. अच्छा, सर्कुलर पिच, सर्कुलर पिच क्या होता है भाई? Circular pitch you have calculated and you have got some distance which is like pitch circle mein, this is my pitch circle. So pitch circle mein you have got this value. This is your PC. This is your PC. And what is the module? If I tell you module will be expressed as diameter by teeth. So this is my diameter. If I divide this diameter by number of teeth, so I'll get some this size. This size. So can I say, if my PC is represented here as the arc, so my module will be in terms of linear dimension. So this is my module, this is my PC. How you are using these as local units? Units का मतलब है like if I have to measure some linear dimension, any linear dimension I can either tell you in the terms of meter, centimeter, mm, or we can also tell in terms of module. And any circular or arc wala dimension, if I have to represent any arc, so I can either use ki bhaiya 10 centimeter, 5 centimeter, or I can use in terms of, I can express in terms of PC. How we are going to do this? Try to understand. Suppose like, what is the value of addendum? If somebody is asking, tell me what is the value of addendum. Addendum is a radial dimension, linear dimension. So if somebody asks me ki what is the addendum ka value, and for my, I have some gear, its module is suppose 10 mm. ध्यान से समझना. If my module is 10 mm and for this gear addendum ka value I got, it is coming out to be 8 mm. Some addendum I have measured and it is about 8 mm. So either I can tell you that addendum is 8 mm, or I can write addendum is 0.8 times of module. How many of you can understand this? Both things are representing exactly same baat, exactly same concept. By 0.8 into module, 0.8 times of module, 80% of the module, I can also tell you my addendum ka value like this. Clear hai baat? This is what I mean when I say I'm using these as local units. Okay? So what is circular pitch? What is module? I hope everybody is clear. Now, very, very careful. We are talking about involute gear. In our syllabus, we are having involute gear. These two terms I have told you. Now let's talk about involute gear. What is involute gear? Involute gear mein teeth I have made with the help of involute curve. What is the involute curve? And what are the properties of the involute? Everybody must be comfortable here. Involute gear. Involute gear mein teeth I am having involute nature ka teeth. These are made by involute. What happened? अरे भाई विकास, प्लीज गूगल इट ना. कंप्यूटर साइंस में वी डोंट हैव इंजीनियरिंग सर्विसेज का एग्जाम. इंजीनियरिंग सर्विसेज एग्जाम इज फॉर इलेक्ट्रिकल, मैकेनिकल, सिविल, electronics, even for electronics I don't think it is there. Electrical, mechanical, civil, for the core branches it is there. For CS, IT we don't have. For DA we don't have. ठीक है, just google it. Involute gear, what is the involute gear? Careful. Sir, what is the involute curve? Involute curve is, it is the locus of any point on the tangent which is moving on us. Careful. Suppose I am having a circle, fixed circle. So how involute curve is defined? Involute curve is locus of a point on a tangent which is rolling on fixed circle without slip. What does it mean? Suppose if I have a tangent means this is a circle, fixed circle, and on this circle if I have a tangent, this is a line, tangential line. If this line is rolling on it, this line is here, next moment but this line moves here, there should not be any slipping. So take any point on this line. Sir, if I am talking about this particular point, so keep tracking path of this point, it will give you a curve which is called as involute curve. Involute curve for this circle, and this circle for which you have drawn the involute, it is called as base circle. Base circle. Sir, is it necessary that I should take only this point? Can't I take this point or this point or this point? Take any point on this tangent. Every point on this tangent will draw involute curve, involute for this base circle. So sir, same thing I can also say it like that if I have a circle, fixed circle, and here I have wounded a thread on it, and if I'm opening this thread without losing its tightness, thread ka tightness should be maintained, so that thread also gives me feeling of the tangent every time. So on that thread if you have attached a pen, so any point will draw a involute curve again for this base circle. Same, by definition wise it is defined as any tangent. Take a point on any tangent which is doing pure rolling motion on a circle, fixed circle, and same thing easily I can draw it like that. Take a circle on which wound some thread, and without losing the tightness, open it. Tightness should be maintained every time. If tightness is maintained, so that thread is giving you feel of tangent. So thread was, suppose I have taken some point, that point was suppose here, thread ko you have opened a little bit, and now that thread looks like this. Thread is here, thread is tangential here. So the point you have attached, that point has moved this side by traveling this arc ke form wala distance. Next moment thread will look like somewhere here, thread is this side, point has traveled this side again by traveling in an arc ke format. Again opened, you have opened the thread, it is tangential here, point is here, you have again traveled a arc kind of distance, है ना? So whatever this curve we are getting, this curve is called as involute curve. This is involute curve. And even a blind person can feel this. Sir, these points which I have shown, this point, this point, this point, imagine these points are very, very close to each other, very, very close to each other. This point, just adjacent point I have shown here. Just adjacent point I have shown here. Just to show you, I have drawn some curves in between. These curves are infinitely small, very, very small. Okay, sir, by looking at this curve, I am getting a feeling that this is the circle type curve, a small circular arc whose radius looks like this, which is having center here. Okay, now I have drawn another circular arc whose radius is this, having center at this point. Another circular arc you have drawn whose radius is this, center at this point. Sir, quite logical baat. And if you are calling these as circles and this as radius, so can I say this radius will be perpendicular to my circle arc K? It will be perpendicular. This radius will be again perpendicular here. This radius will be again perpendicular here. Yani ki this beautiful property of the involute curve, remember this, I will be using this in analysis of my involute gear. Yani ki on this involute curve, if I draw perpendicular anywhere on the involute curve, that perpendicular is going to be tangential to its base circle. Let me write perpendicular drawn at any point on involute curve is tangential to its base circle. Can you understand this? How? Sir, I just have shown it. Clear, clear, clear hai baat. Now, another circle I have got. I will be having base circle also. Earlier I haven't shown. Now I am showing that involute gears may you will be having another circle called as base circle. Careful. Sir, how using some base circle you are going to make teeth? For making teeth, I'll be having this kind of situation that we are having a base circle. You have chosen a base circle. Okay, you have chosen a base circle. You have drawn involute curve. अब involute curve कैसा है? Sir, you have drawn, you have opened the thread and curve you have got it. From this side also, open a thread, you will get some curve like this. You have got these two curves and these two curves ko I'll be making my faces of teeth. Sir, if you make this as your teeth, so your teeth is going to have some pointed tip. I don't want pointed tip. Pointed tip is unstable, it can break easily. So what I have done, I have at the time of manufacturing itself, I have taken shape like this, shape of the teeth like this. So my tooth looks like this. Why? Because there is no use of the tip. I will be having my teeth and teeth ka this portion is going to be in contact. This portion is going to be in contact with another teeth. This top land, this, it is not any, it is not of any technical use to me. I don't want that tip. Clear hai baat? So outside the involute, outside the base circle, I am going to have my teeth ka involute curve. If any portion of the teeth is inside the base circle, that curve is not going to be involute. For being involute, I have to be outside the base circle. Now, as a matter of fact, let me tell you that when we are going to have gears, how that gear is going to look? Sir, we just have seen that we are having dedendum circle, and on that dedendum circle we have made teeth like this. So my teeth looks like this. Are bhai. This is my teeth. This is my gear, addendum circle, and this is my teeth. let me make it a little thin. ऐसा कुछ, you will be having teeth like this. From wherever teeth is started, it is called as dedendum circle. From the tip, you will be having addendum circle. Somewhere in between, I have shown you pitch circle. And one more new circle I have got for the involute gears. I am having this is called as base circle. Base circle. Where this base circle looks, base circle is below the pitch circle, above the dedendum circle. And how many of you can see this? That sir, this entire tooth, its some portion is above the base circle. This portion is going to be involute in nature. Yes, sir. This portion is going to be involute in nature. This portion is going to be involute in nature. यानी कि this involute portion, if it is contacting other gear का involute portion, it will be behaving good as a gear. Law of gearing will be satisfied. If other gear ka teeth is coming inside the base circle and touching here, this portion is non-involute in nature. So this portion is non-involute, this portion is non-involute. Let me write, we are having some portion inside the base circle also. This portion is non-involute in nature. This is non-involute. How much portion is involute? Only this portion is involute. So involute tooth must be in contact with the involute portion. If other gear ka tooth is so big that it is coming inside the base circle and touching here, I will say a bad, deadly phenomena is going to take place, which is called as interference. I will say other gear ka tooth is doing interference here. This is your responsibility. You have to ensure this, that other gear ke tooth should not make contact here inside this base circle. I hope this is clear to everyone. Otherwise, a phenomena named as interference is going to take place. And to avoid this interference, we have entire chapter we have dedicated how to avoid this interference. What are the things which we can do here? ठीक है, चलो. Now let's talk about analysis wala part. If we have understood these properties, these beautiful things, we can further discuss about analysis of involute gear. Let me talk about analysis. Analysis of involute gear. Careful. Sir, whatever important circles are there, I am going to just show you those circles. क्या दिखाई पड़ रहा है? I am having my pinion का pitch circle. Sir, this is my pinion का pitch circle. If you have understood what diagram I am going to make here, in this chapter there is nothing. If you cannot understand this diagram, in this chapter there are so big heavy formulas, you will not be able to remember that, and you will not be able to solve any subjective question. Try to understand this diagram carefully. This is my pitch circle of the pinion, है ना, small circle, and then I have gear. This is my gear का pitch circle, and both these circles are touching at some point, which is called as pitch point. Sir, this is your pitch point. दिखाई पड़ रहा है? This is the line which is joining the centers. Radius of pitch circle of the pinion is given as small r. Radius of pitch circle of the gear is given as capital R. It is customary that everybody is doing this. We are also doing this. Small letter से I will be denoting terms of pinion, and capital letter से I will be denoting some terms of gear. Number of teeth, small t. Number of teeth, capital T, like this. And this is my driver. Driver को I am representing as DVR, driver, and this is my driven body. है ना. This gear is my driven body and this is my pinion, which is my driver. Always, generally we make pinion as driver. So these pitch circles are touching. Now we are also going to have some teeth. Where are the teeth? Teeth is radial positions where we are going to have teeth, and teeth will be, some portion of the teeth is below the pitch circle, some portion of the teeth is above the pitch circle. So teeth will look like this. This is the teeth. Another teeth radial position mein I'll be having like this. Another position mein, radial position mein I'll be having teeth like this. So radial position mein we are having teeth here. On similarly we are also having teeth on this. We are having teeth like this. Radial position mein we are having teeth like this. So many teeth we are having. So let me draw addendum circle. How that addendum circle is going to look? Addendum circle is, or first of all let me show you the base circle. Where is the base circle? Sir, base circle is inside the pitch circle. We are having base circle. So base circle is a little smaller size ka. This is my base circle, pinion ka base circle, and we are also having gear ka base circle. This is my gear ka base circle, pinion ka base circle, and this is my gear ka base circle. Let me change its color. Its color is yellow. Okay, let me write what are these circles. This is my base circle of pinion. This is my pitch circle of pinion. This is your base circle of gear. This is your pitch circle of gear. And we will be having some addendum circles also. Teeth is extending beyond the pitch circle also. So this is your pinion ka addendum circle. What is the meaning of this addendum circle? Whatever teeth we are having, teeth will be till this addendum circle. Beyond addendum circle we don't have teeth. Similar way say I'll be having some addendum circle of the gear. Addendum circle of the gear is bigger than pitch circle. Sir, it looks something like this. So this is your addendum circle of pinion, and I have also shown addendum circle of the gear. Can you see this clear picture? Thick circles are representing the pitch circles, and then we have some small thin lines here. I have shown base circle, addendum circle for the pinion, and base circle, addendum circle for the gear. Pitch circle se inside base circle, pitch circle ke outside we are having addendum circle. Similar way say I have shown it for the pinion also. Now imagine kariye that if my pinion is driver and it is rotating in clockwise direction with some omega p angular speed. Any teeth which is radially extending here, we are having teeth like this, and this teeth is moving clockwise direction mein, and one teeth of the gear, it was waiting here. Suddenly this pinion ka tooth has came in contact with the gear tooth, and pinion ka tooth will be applying some force, and that force will be how it will be looking. We are having tooth, pinion ka tooth is this. Sir, ye pinion ka tooth hai. This tooth is coming and it is going to be engaged with gear tooth. Sir, gear ke tooth, how they will look? Sir, this is the center. Radial direction mein we are having, this is the teeth. Pinion ka tooth, it is rotating clockwise direction mein with some omega p angular speed. On the other hand, gear ke tooth kaise nazar aayenge? Gear ke tooth we are having some yellow color se I have shown it. They are also in radial direction. Radial direction ka matlab hai something like this. We are having, careful, sir, this is the situation. Its center is somewhere here. Radial direction we are having another teeth. Radial direction we are having pinion ka teeth. Can you see? Let me just delete this line. Can you see? Both these gear will somewhere come in contact. Can you see? Somewhere these teeth are coming in contact. Sir, involute portion of the teeth of the pinion is in contact with the involute portion of the teeth of the gear, and by direct contact at this contact point. This is the contact point. Sir, this is the point we are calling as contact point. So by direct contact, my pinion ka tooth is applying some force on the gear ka tooth. And where will be that force? Contact force. Everybody knows contact forces will be whenever two surfaces are touching each other. So contact force will be at this contact point. Surface ka normal if you will draw, I'll be having force acting in that direction. Where will be this force? That force will be, draw a common normal. This involute curve, it's normal. This involute curve, it's normal. Common normal. So that common normal looks like this. Sir, if this normal you are saying it is tangential, it is normal to this involute curve. Involute ka normal is tangential to its base circle. So pinion ke base circle se it will be tangential, and it is normal to gear teeth also. So it must also be tangential to the base circle of the gear. So a line which I am getting here, line of action, force will be acting in this direction. Line of action will be a line which is tangential to this base circle as well as tangential to this base circle. It must be tangential to both the base circle, and that line which I am getting, the line which I have got is something like this. It must be tangential to both the base circle. So, sir, pinion ke base circle ko it is touching. It is not touching here. So, let me correct the base circle. Let me correct the base circle of my gear. Gear ka base circle, let me make it a little smaller so that line of action is looking tangential. Sir, what are you doing? Why are you changing the diagram? Arey bhai, I am changing this diagram, just I want to show, because I want to show that both the gears should have base circles in such a beautiful manner that whenever I draw normal, it is passing through, it is tangential to both the base circles. It is tangential here at this point M, and this is your point N. Okay? This is your radius of base circle of gear. This is your radius of base circle of pinion. Can I write this? Sir, this is your radius of base circle of the gear. This is your radius of small RB. Radius of base circle of pinion. And let me write this as capital RB, small RB. This is perpendicular. This is also perpendicular. Let me zoom this a little bit. Can you see how I have shown? This green color say I have drawn my line of action. This is your line of action. Force is acting in this direction. This is your line of action. Force is acting in this direction. Perpendicular, perpendicular. This line of action is tangential to the base circle, and this radius is perpendicular here. I hope this is clear to everyone. Okay? And whatever line of action is making angle with common tangent at pitch point. This is the common tangent which I have drawn at pitch point. Sir, this angle is called as this angle is called as pressure angle. Sir, ye jo angle hai na, this angle between these two lines, common tangent and line of action, this angle is called as pressure angle. This is denoted by phi, pressure angle. What is the use of this pressure angle? Can I say, sir, you are having force in this direction, green wala line. So one body, gear, pinion ke tooth have applied force because of the direct contact in this direction, and force ka one component I can take here in this direction. One component I can take in this direction. Let me take this diagram in another page. If I take two components, what are the forces applied by pinion tooth on the gear tooth? Sir, this is the force. I am taking force ka one component here, force ka another component here in this direction. So can I write force F ka one component F cos phi is here, and this is the F sin phi. Can you understand? Arey sir, whatever force is acting on the tooth in this direction, this force multiplied by radius of the pitch circle, this force multiplied by radius, it will be giving me torque. This is the torque component, and because of which my gear is going to have some rotation. Can I say this? If I just remove all this thing, can I simply say force K, I can take two components. This force will be having two component. One F cos phi component, which is providing me torque. If somebody is asking, tell me what is the torque acting on the gear, I will say torque acting on the gear, it is force F cos phi multiplied by radius r. This is the torque which is acting on the gear, and because of this torque my gear is going to rotate. This component is of my use. By my intention was that pinion will be applying some force, gear will rotate. Because of this component my gear is going to rotate. What is this F sin phi? What this component is doing? This component is rubbish. F sin phi, it is of no use to me. Useless component. Useless. This is the radial thrust. Radial thrust. What is the meaning of radial thrust? Radial thrust का मतलब होता है that this is the shaft board के perpendicular, another shaft perpendicular to the board. So whatever forces I have applied, one component is in this direction. So this force is actually applied on the shaft. We are having one shaft towards you, one shaft towards you. Gear pinion के tooth have applied force, and one force component is applied on the shaft. It is trying to separate the shaft. Radial thrust. It is of no use to me. I don't want this component, but this will be there. I want this component to be as less as possible. I want this component to be maximum. है ना? So phi should be maximum के लिए this phi will be 0, but 0 is not possible. So I want this phi should be very, very close to 0. You know, 10 degree, 12 degree, 15 degree, 20 degree, 25 degree, not more than that. Pressure angle should be less than or equal to 20-25 degrees. Max to max values of phi, which is used in practical, it is 20 degree, 25 degree, not more than that. Clear है ये बात? ठीक है? Coming here again at the analysis वाला part. Sir, where your contact is going to start? Sir, ध्यान रहे एक चीज का. I have shown one picture. Contact point is looking here. Now these teeth, they will also move. So contact point will move. And another time, another instant पे, wherever you are having contact point, again you will draw the common normal to get the line of action, force. So that perpendicular again it is going to be tangential to the base circle of pinion as well as of the gear. So that line will be again tangential to base circle, same line I am getting. It means your contact point, it has to move along this line only, no other choice. So contact point, it will start somewhere and slowly it will move along this line. Let me zoom this a little bit. Where this contact point is going to start? Sir, first, for the very first time, pinion के teeth are coming. Gear के tooth का tip is going to touch somewhere and contact will start. And slowly these things will move, and at the end, pinion का tooth, driver body का tooth will touch, tooth का tip will touch somewhere and they will separate. When I am saying this word tip of the teeth, it is indicating the addendum circle. So contact point have to be along this line of action only. Contact point will travel along this line of action only. And for the very first time, when you see this intersection of the addendum circle to this line of action, I will say contact will start here. Addendum circle of the gear driven body, wherever it is cutting line of action, contact will start here. Let me call this point K. And when tip of the driven body, tip of the driver, which is pinion here, whenever it is going to touch line of action somewhere, here contact is going to end. I am calling this as point L. So at point K, contact will start. Contact will be sometimes here, it will be sometimes here, it will be sometimes at the pitch point also, and slowly at this point L, disengagement is going to happen. This is your point P, this is your pitch point P. So contact point starts at point K, moves towards point L in this straight line. Examination mein how they are going to ask question. If you have understood this diagram, whatever questions they are going to ask, you can simply answer that. First question, careful, sir, what is the total path of contact? Yani ki contact point is started at K, how much distance your point of contact has traveled throughout the engagement? This is called as KL distance. KL distance. This is KL distance. Path of contact. KP is called as path of approach. Teeth are getting engaged, and from P to L distance, I am calling it as path of recess. Teeth are going to disengage. They are moving towards the disengagement. How can I find out this? Simple logic. Don't try to remember this. Don't try to memorize these as formulas. I'm not giving you any formula. बहुत ध्यान से. Sir, if this is the radius of the addendum circle, this is the radius of addendum circle. Look at the diagram carefully. Let me call it as capital RA, radius of addendum circle of gear. This is angle phi. This is angle phi. So this will be 90 minus phi. This angle is 90. So what will be this angle? Phi. Can I say this angle as phi? Now look at this triangle. This triangle, right angle triangle hai beta. R, this is R cos phi. And this triangle, can I write? This is R cos phi. Base circle ka radius is R cos phi. And this value is how much? You can call it as R sin phi. Simple si baat. Now, if you want to find out this Kp ka value from this triangle, this is also right angle triangle beta. Can I write Pythagoras theorem here? Capital RA square, I know this, radius of addendum circle will be given to me. Capital RA square minus this value, base circle ka radius square, this square minus this square, take its under root, you will get this value. And what is this value? This value you can write as Kp plus this distance, and this distance is R sin phi. Subtract R sin phi and you will be left with value of Kp. So how I am writing this? Kp को क्या लिख सकते हैं? Kp directly I am writing Kp is under root sir, I am writing RA square minus R cos phi square. RA square minus R cos phi ka whole square. Take its under root. You are left with this big value. And subtract R sin phi minus ka R sin phi. You are left with Kp ka value. Now, if you want to call this as formula, you can call this as formula. Try to memorize this. If you have understood the diagram logics, you can simply close your eyes. Diagrams will be in front of you. Kp ka value is how much? This much. What is the PL ka value? Similarly, you will write PL ka value. That will be in terms of small r. Pitch circle ki radius ke terms mein. It will be under root small RA square minus R cos phi square minus R sin phi. Tell me in the chat box, is this clear or not? बताइए बेटा, क्या ये बात समझ में आ रही है? Everyone, are you able to understand this? Once you have Kp plus PL, so what is path of contact? Path of contact KL, I can write this as Kp plus PL. Kp is called as path of approach. We just have calculated this. Path of approach. PL is called as path of recess. Path of approach, path of recess. That's it. Simple si baat. Tell me in the chats. Anyone having any problem? Yes, beta. in this entire gear chapter, formulas may look tough, but it is not tough actually. Now, once you have calculated this path of contact, we also have a term which is called as arc of contact. Arc of contact. What is its value? Arc of contact ko we can define as path of contact divided by cos phi. This is the formula. Acha, this is the formula. How do we define this? Actually, this arc of contact is analogous to path of contact, similar to path of contact, but I measure this distance along the pitch circle. But measured along pitch circle. Pitch circle. है ना? Path of contact we just have calculated. KL का value. Put the value here, divide by cos phi, will be getting arc of contact का value. एक चीज का ध्यान रहे. One thing I want to write here, that sir, point of contact moves along the straight line. First point. Point of contact, sometimes it will be coinciding with pitch point, another point. And starting from the engagement till the point your teeth were engaged, tooth came in contact, they were engaged for some duration and they got disengaged. Another pair came in contact and they were engaged for some duration, then they disengaged. This is how it is happening here. So for this, during entire engagement process, phi is not changing, pressure angle is constant, and that's the beauty of involute gear. Phi remains constant. Phi remains constant during entire engagement. Entire engagement. I will not show you cyclodal gear, but analysis like this deep analysis we are not going to do. But from here I am just making one statement that involute mein this is constant, cyclodal mein it is not constant. Cyclodal mein it varies. At the starting of the engagement, cyclodal teeth if you are having, so at the start of the engagement you will be having maximum pressure angle. Slowly it decreases to 0 and then again it starts increasing towards the maximum value towards the disengagement. Clear है बात? बताइए बताइए. ठीक है. Arc of contact, how does it look? Sir, path of contact, how does it look? I have seen this. Arc of contact, how does it look? Let me show you that. Again, I am taking this bigger picture. I am removing few things from here. है ना? Very, very careful. I am just removing all these things. If I'll just show you only one part, only some portion of the diagram I have removed so that you can focus. Sir, pinion ka situation looks like this. Contact has started here, sir, point K per. It has ended at which point? Point L per. So actual path of contact is traveling here. So when actual path of contact was traveling here, one teeth was somewhere at this location. Radial position mein one teeth was there. How that tooth looked? So that tooth looked like this. We were having tooth like this. Tooth looked like this. Radial portion mein the tooth was here. Can you see this? Sir, whatever tooth came here, another gear ka teeth has touched here. contact has started, and slowly when this tooth has traveled its next position, let me just make this a little more clear. Sir, I'm making tooth like this. This is my tooth. So one tooth will be at the start, tooth will be somewhere here. Tooth was looking like this. Contact point has started here at point K. Radial position I have drawn this, and this teeth slowly it will move till this point. Same teeth, it has traveled till this point, and now disengagement has happened. What its radial position will look like? Sir, initially radial position was this, and now this teeth has traveled here. Careful. Initially tooth was looking here. From this radial position, my tooth has traveled this distance. Actual contact point has moved from here to here. How much distance your tooth has traveled along the pitch circle, that's what I want to measure. And this distance you can write like this. Sir, take on this teeth, take any point. I am taking this point. So take how much this point has traveled on this circle, pitch circle. Or you can also talk in terms of this radial portion to this radial portion. This will be equal to arc of contact. So when your actual engagement has happened, from the start of the engagement to the end of the engagement, point of contact actually it was moving along this line, a straight line. During the same time, how much your tooth has traveled along the pitch circle, this distance is called as arc of contact. So how does it look? Take any point from here to here. You can take this distance, or you can consider this also. So from here I have considered this distance, same distance, obviously baat hai. Take any point, and this point has traveled how much distance when contact is started till the contact was there. बात समझ में आ रही? Sir, why are you measuring this? Sir, when you get this arc of contact का value, whatever it is coming out, this arc of contact is going to give you idea about how many pairs were engaged. Contact ratio we call it. Arc of contact we have calculated. It is the arc wala distance, and arc wala distance ko you can either tell me in terms of something mm, ki sir I have calculated this value is coming out to be 15 mm, 20 mm, or you can write this in terms of local unit. I have said local unit, if you are measuring some linear dimension, in terms of module you can write. If you are measuring some circular arc wala dimension, you can write this in terms of circular pitch PC. So you can write this arc of contact in terms of something times of PC. It is equal to 1 PC, 2 PC. So sir, when tooth came in contact, until the time this tooth was engaged, it has traveled if exactly 1 PC. 1 PC. 1 circular pitch. And 1 circular pitch mein we are having 1 tooth, 1 space. That means 1 tooth, 1 space. This 1 tooth was in contact with another tooth there. For 1 PC they traveled and they got separated. So 1 PC mein only 1 tooth was engaged with other gear. So what is the contact ratio? Contact ratio, number of pairs engaged in one engagement zone. If this value of arc of contact is 2 PC, so 2 PC, what does it indicate? Sir, 2 PC ka matlab hai that when contact is started till the time contact was there, this dimension is twice of PC, and twice of PC, 2 circular pitch mein how many tooth will be there? Sir, 2 teeth, 2 space. So these 2 teeth will be engaged. So whatever teeth are falling in this zone, they will be engaged with other gear. So how at any instant how many pairs are engaged, that number is nothing but contact ratio. Can I write? So this 1 PC or 2 PC, this gives me number of pair engaged during one engagement zone or duration. Sir, logic say if I can say this thing, that contact ratio ka value, I want it to be more than or equal to 1. Sir, more than or equal to 1 means if you want to have continuous motion transmission, that from gear 1, continuously motion should be transferred to gear 2. How many pairs should be engaged? At least one pair should be there. Why? At least one pair of pinion should be engaged with gear. They are transferring the motion, and the moment they disengage, immediately another pair should be in contact. Then only we will be having continuous motion transmission. Anything more than one, I am happy. So two pairs are in contact, I am happy. That two pairs together, they are sharing the load. So these two pairs are in contact. At any time when this second pair disengages, another pair will come into picture. So whenever you will see, always you will find two pairs engaged. That is the meaning of 2 contact ratio, 3 contact ratio. बात समझ में आ रही है? So examination में they can also ask, tell me what is the value of contact ratio. ठीक है. Now the biggest problem arises. What is the biggest problem? Biggest problem is interference. How do we avoid this interference? First of all, try to understand what is the meaning of interference. Interference, when it happens, and how to avoid this. Examination mein questions are asked. If I draw, this is the pitch circle of pinion, pitch circle of the gear, pitch circle of pinion and pitch circle of the gear. This is the line which is joining the centers. Small r, capital R. Radius of the pitch circles I have shown. Small r, this is my capital R ka value. Sir, line of action will be somewhere like this. This is your line of action. Passing through the pitch point, this is your line of action. Forces are acting here. Draw a perpendicular here, which is representing the base circle ka radius of gear, and draw a perpendicular here representing the base circle of pinion. Okay, these are the points you have called as point M, and this you have called as point N. They are the perpendiculars representing the radiuses. Imagine kariye, we are having base circle here, we are having base circle here also. Let me draw base circles also. Base circles will be like this. One base circle looks like this. Another base circle of the gear looks like this. Tell me in the chats. Clear hai beta ye baat? Now, sir, point K and L, where contact starts, where contact ends, how these points are decided? These points will be decided by the addendum circles. Like pinion ka addendum circle, if it is this, so point L you will get here. If the addendum circle is even bigger, you will get point L here. Addendum circle means your teeth ka size. So teeth is this, or teeth is bigger, even bigger, even bigger. So if your teeth are growing bigger and bigger and bigger, so addendum circle will be somewhere here, point L will be here. So if it is even bigger, point L will be this side, even bigger, point L will be this side. So if your teeth ka size is increasing, if pinion ke teeth ka size is increasing, so point L, which you are actually getting somewhere here at this point L, this point L starts moving towards this point N. Till point N, I don't have any problem. But if size of the addendum circle of the pinion is beyond this, the circle which I have drawn, it will be a situation where point L is exactly at this point. Your teeth are so big that they are touching gear ke tooth ko exactly at this base circle. Imagine kariye, if you have made even bigger, let me draw. Sir, this is the circle which you have got. This is the addendum circle for which your gear tooth, sir, gear tooth will be radial position mein, your gear tooth will be radial position mein. Let me draw This is your gear tooth. Sir, this is my gear tooth. And gear tooth ka outside the base circle you are having involute gear. Inside the base circle you are having non-involute portion. Imagine if your circle, addendum circle of the pinion is anything bigger than this red circle. Anything bigger than this red circle. Can you see this? Can you see this picture? Okay, sir, anything bigger? Arey yaar. Anything bigger? Sir, now my teeth are so big. If teeth was till this point only, if teeth was till this point only, my involute teeth of the pinion tip was touching at the base circle. If it is slightly bigger, it will start touching inside the base circle. That is a problematic situation. I have already discussed that inside the base circles we are going to have non-involute portion of the teeth. Getting a point? And that's what I say, sir, my pinion teeth has started doing interference on the gear tooth. बात समझ में आ रही है? So if more than this value of the addendum circle you have taken, your pinion is doing interference on the gear. Similar logic say, sir, you were having point K somewhere here. Who decided this point K? Sir, point K was decided by none other than radius of the addendum circle. Addendum circle of the gear, if it was here, so point K was here. If it is bigger, point K will be this side. If even bigger, K will be coinciding with point M. Till point M, I have no problem. But if your radius of the addendum circle of the gear is more than this value, it will be a situation where I will say my gear tooth are so long that they are touching my pinion ke tooth ko inside the base circle. Gear tooth is doing interference on the pinion tooth. Whether pinion does the interference on the gear or gear does the interference on the pinion, this is a problematic situation for me. I want my pair to be safe. I should guarantee that pinion should not do battimiji on the gear tooth and gear should not do any kind of battimiji inside on this pinion tooth. बात समझ में आ रही है? And for this purpose, we have reduced size of the teeth. We have reduced size of the tooth. Sir, there are so many other methods also, है ना? How to reduce chances of interference. How do I reduce chances of interference? Sir, first suggestion comes that you are actually having tooth like this, and this is suppose your base circle. We are having this as your base circle. Dedendum circle, this is your base circle. A student suggested कि अरे sir, the opposite teeth is so big that it is touching inside. What is the problem? Sir, law of gearing is not satisfied, first thing. Second thing, this is not a smooth contact. The opponent's teeth ka tip is actually going to scratch some portion of the material here. That teeth is scratching some material from here. It is like metal cutting is happening. So this will get destroyed. Opponent's tooth ka tip also get destroyed. So we have beautifully made involute, beautiful curves, beautiful teeth, and now they are getting destroyed. So to avoid this, one student suggested ki sir, do one thing. At the time of making the gears, you by yourself remove some portion of the material from here. Remove some portion of the material from here. Now the teeth which we are going to have, the teeth will look like this. Tooth ka shape looks like this. What happens? Sir, when opponent's tooth comes here, even if the opponent is having bigger tooth, if it is coming here, now that opponent's tip is not finding any material because you have already removed the material. So there is no clash between these two. Interference is avoided. But can you feel this? That you are actually making this teeth weaker. You are reducing the cross section. है ना? So this is called as undercutting. Up to a certain extent, people do this. Undercutting. But undercutting se sir, chances of interference are reducing? Yes. But the drawback is power, power torque transmitting capacity also reduces. Strength of the tooth reduces. Strength of tooth also decreases. This is the drawback. So does this thing reduces the chances of interference? Yes, but we cannot do it always. Why? Heavy duty operations ke liye, if I need some gears, so teeth will break. Another student suggested, he said, do one thing. Second thing. Sir, why don't you reduce the radius of base circle? Decrease radius of base circle. What will it do? Arey sir, you have taken this dedendum circle, this is your teeth, and you decided that this is going to be your base circle. Inside the base circle, you were having non-involute portion. This was your non-involute portion. Now, opponent's tooth, it was coming here, touching it. You were saying interference is happening. Why you have taken this base circle? What if you take base circle a little smaller in size? What will happen here? For this new base circle, below the base circle, this much portion only is non-involute. Now, above the base circle, this portion, which was earlier non-involute in nature, now this entire tooth is involute. Yes or no? Now, what happens here? Sir, now this opponent's tooth, same size of the tooth. Earlier it was doing interference. Now, if you have changed the base circle, reduced the radius of base circle, now it is not doing interference. Yes, good idea. Up to a certain extent, you can also do this. But the problem here is that as radius of base circle reduces, my pressure angle starts increasing. And pressure angle में there is a limit कि भैया pressure angle max to max 20 degree, 25 degree, not more than that. So you cannot do this randomly कि just keep on reducing the base circle radius. It is affecting you adversely. Why I am saying this? Arey bhai, look at this. Here I have just told that pressure angle as minimum as possible, it will be good for you. Radius of base circle, sir, you have taken this radius of base circle, this radius of base circle. If you reduce the radius of base circle here, reduce the radius of base circle here, so obviously baat hai, the common, whatever involutes we are going to get, involutes, they are touching somewhere, draw the common normal, that line of action should be tangential here also, here also. And if these base circles ka radius you have reduced, can you feel the line which is here, next time it will be passing through like this. Pressure angle increases. So as radiuses of the base circle reduces, pressure angle starts increasing. I don't want this. Bataiye. So you can do this up to a certain extent, but not randomly. Adversely, it is going to affect. Third thing is, we call it as, why don't you do stubbing? Sir, stubbing का मतलब होता है that why the opponent tooth, now I am showing you the opponent tooth. This opponent tooth is so big that it is touching the other tooth at that point where it should not touch. Why don't you control its height? Tooth is looking like this. Sir, you have made this teeth so big. This is your addendum circle. If I remove this much portion, sir, if you remove this portion, new addendum circle will be this. Are yes or no? New addendum circle will look like this. This is your new addendum circle. Does it help in reducing the interference? Yes, it does. It does. By this teeth was so big in size that it was touching at some non-appropriate portion, non-involute portion. Now you have reduced the height of the tooth. Obviously, it was earlier doing interference, now it is not doing interference. But the problem is, as you start reducing the height of the tooth, path of contact will also start reducing, arc of contact also starts reducing, contact ratio starts reducing, है ना? And there is a limit. You randomly you cannot do कि sir let's do stubbing without thinking anything. Contact ratio पे it affects adversely. You do stubbing, contact ratio decreases. This cannot be less than 1. It has to be more than or equal to 1. So you cannot randomly do stubbing. Clear hai baat? Contact ratio, there is a limitation that contact ratio have to be more than or equal to 1. Simple si baat. Another person suggested ki sir, why don't you do? Fourth suggestion is, why don't you increase number of teeth? Chances of interference ko I am trying to reduce by increasing number of tooth. Careful, sir. How by increasing number of teeth it is going to help in reducing the interference? Imagine kariye, sir, this is your dedendum circle, and you have earlier used this big size tooth. These are your tooth. For involute tooth, using this base circle, this was your base circle. Same base circle I am using. Sir, base circle pe you have a thread, and on that thread you have taken any point. Its path you have taken as involute. Sir, can I take any point on that tangent? Will it draw involute? Yes, it will draw involute. Sir, coming back here, you have taken this end point, its path is involute. Okay. What if I take on the same base circle tangent ka any other point? If I have taken this point, so it will be drawing this parallel curve, involute. Okay. What if you take this point? It will draw another parallel curve. It will also be involute. If you will take this curve, it is also involute. So same base circle, say you can draw so many involute curves, parallel profiles. Same logic I'm using. What does it mean? It means that earlier teeth were this big. Now you have taken parallel curves. Parallel curves look like this parallel curve, this parallel curve. They will be cutting at some they will be intersecting and making some tip. So tip ko I have to avoid. So I have taken this line. Sir, tooth ka size has reduced. When I say tooth ka size has reduced, everything, its thickness, its spaces, height, everything has reduced. Same base circle I have used, to pressure angle where there is no change first of all, and height of the tooth automatically has reduced. So earlier my addendum circle, if it was this was my addendum circle, now automatically your new addendum circle is a little smaller. Yani ki without doing stubbing, your tooth height has reduced. And once your tooth ka height has reduced by this amount, obviously baat hai, this big size tooth was doing interference. Now this smaller tooth is not doing interference. And by doing this, there is no adverse effect. There is no adverse effect at all. By all other three methods which I have used, there were some adverse effects. Somewhere pressure angle started increasing, contact ratio started decreasing, tooth becomes weaker. Here there is no such restriction. The only thing is that by increasing number of teeth, tooth ka size decreases, interference decreases, but as number of tooth increases, cost increase karti hai. And that's why we don't randomly increase number of teeth. We go for some optimization. Okay, sir, tell me the minimum number, at least how many teeth I should provide so that interference can be avoided. Whatever numbers you are going to get, any number beyond this, you are safer. Right? Number of teeth we are increasing on the, imagine karo, same pitch circle. Earlier you were having teeth like this, bigger teeth, big size teeth. We were having teeth like this. You are having, arey bhai, you are having radial teeth like this. Earlier you were having teeth looking like this. Ye big size teeth you are having. Now what you have done, same pitch circle mein you have started using smaller teeth. Ab smaller teeth ko if you are using, so earlier situation was this. Now what we are doing, we are using a smaller teeth. A smaller teeth, obviously baat hai, numbers will increase. Sir, now teeth looks like this. Now we are having teeth like this. So can I say, by reducing number of, by increasing number of teeth on the same pitch circle, my tooth ka size is reducing automatically. So number of teeth increase karne se size is reducing. Whatever, we will be having some formulas here. That formula will give you some number. Ki bhaiya, at least these many teeth you have to provide. And if you have provided at least these many teeth, your size is under control. Further, you are increasing the teeth. Number of teeth you are increasing. Tooth are even becoming smaller. No problem. So formulas will give you minimum number of teeth. From here comes the concept of minimum required teeth. Minimum number of teeth ka formula comes here. बताइए बताइए बताइए, एवरीबडी कंफर्टेबल? ठीक है. The formulas which we get from some analysis, pinion mein how many teeth I should provide? Teeth on the pinion should be more than or equal to, or I can say minimum teeth should be equal to this value, twice of AP divided by under root 1 plus G plus 2 sin square phi, outside the root minus 1 we are having. And similar logic say gear may be we have to control the teeth by pinion ke, if you are increasing number of teeth on the pinion, so you are controlling the size of pinion tooth. If size of pinion tooth is under control, pinion is not doing interference on the gear. Now you have ensured the safety of the gear. Pinion is not doing batmeezi on the gear. Also ensure the safety of pinion. Now gear ke tooth are big. Also control the size of gear tooth. How? Increase number of tooth on the gear also. So how many teeth on the gear at least I should provide? This capital T should be more than or equal to twice of AG divided by under root 1 plus 1 upon G plus 2 sin square phi minus 1. We have got this formula. So using these two formulas, further we solve the equation. I hope this is clear to everyone. Simple si baat. So I hope in this chapter, quickly we have got an idea in a perfect manner that how gears are going to work, how path of contact, arc of contact, how this analysis wala part is done. No need to remember or memorize anything. Just try to understand the concept. If you have understood the concept, things are very easy for you. ठीक है ना? You can scan this QR code or find me in Telegram as Vishvajeet Sir PW. This is my group. You can be in touch with me using this group. I'll be there 24/7 connected with you. There are so many similar, same goal wala people. Those students who are working for GATE and IES, they are part of this group. You can have a healthy discussion with all those, whatever problems you are having in your subject, everything you can discuss with all those students as well as with me also. Okay, let's stop. Abhi filhal ke liye we will as of now we will stop here. Tomorrow sharp 8 again we will meet, and tomorrow we will be discussing about this. This was gear chapter. Tomorrow we will be meeting for gear train. Two gears in contact, we call simple as pair. If multiple gears are required, for what purpose I don't know. Tomorrow we will see this. If more than 2 gears we are using, that is called as gear train. What purpose it is going to serve? What are types of gear train? We will tomorrow see this. Sharp at 8 p.m. I will start the class. Stay with me on time. Sharp 8 p.m. ठीक है? चलिए, let's stop. See you tomorrow sharp at 8. Thank you बच्चों.